So I'm talking about smoke and fire behavior and what they mean. So for a fire to burn, you're going to need your oxygen, your fuel, and your heat source. Take away one of those things and the fire goes out. So say we were to take out the oxygen side of things, right? I'm going to do a fire experiment where I'm going to light some matches, cut off the oxygen, and you're going to watch how it's going to fight for oxygen and suck up the liquid through the container. Fuel. Heat. Oxygen. Now, if we cut off the oxygen, you can see how in the container it sucks up the oxygen while it fights for air. That's backdraft. So, basic thermodynamics, right? So, when things heat up, they expand, and when they cool down, they contract, right? So, we see this all the time, even in like freeways, the little gaps there are for when it gets hot outside and it gets cool outside, it has room to move and doesn't crack the whole freeway. With that said, heat rises and cold sinks. So, when you're inside a structure, there's this layer, it's called the thermal layer, also known as the neutral plane, and it's pretty much just a barrier of smoke. And the reason that we go into structures crawling, or I guess you could say on our knees when we're making a push, if it's pretty big, is because like above us, the air temperature is way hotter. We would get burned if we were to stand up, and that's why we stay close to the ground, because it's cooler. And with that said, say this house was on fire and it has fuel and it has heat, it doesn't have oxygen. If you were to open the door, all the hot smoke would come out on top, cold air would flood in on the bottom, and you'd get an explosion. So sometimes this happens. It's called when the fire breathes, I guess you could say. So it creates its own atmosphere, and it gets so hot and the air expands so much and the pressure rises inside the structure, it can pop a window open, and if that happens, it's not too good. But that's why we have truck company. So they go on the roof and they cut a hole called vertical ventilation, which lets out the hot smoke, preventing backdraft. Now, say we took out another leg of the fire triangle and got rid of heat. So that is called flashover when the heat is introduced. In this demonstration, you have your fuel, your oxygen, but no heat, and say you're heating up the air temperature around it, and once that air temperature heats up enough, flashover. And that's why we have to be careful of those conditions and monitor them so we're not in there when that happens. And the best way to monitor them is by reading smoke. So what is smoke? So smoke is just the visible byproduct from combustion. So burnt and unburnt gases, because a lot of times it's not always a clean burn. A lot of particles don't get fully burned all the way, and that's called a dirty burn. So to demonstrate this, I'm going to put out the candle, ignite the smoke, and it's going to reignite the candle. However, smoke's only the visible portion from the byproduct of combustion. So there's also stuff you can't see. So heat and like stuff like phosgene gas, hydrogen sulfate, carbon monoxide, just terrible things that'll screw you up. So that's why we wear BAs. But back to reading smoke. So what color the smoke is. So Class A fires, so wildland, wood, paper, that type of thing, is generally going to be a lighter colored smoke. You're not going to see black smoke coming from a field of burning grass. But you see black smoke and dark smoke in structures, and that's because in structures, there's a lot of different polymers, plastics, hydrocarbons, synthetic materials, just a bunch of crap that we're burning nowadays. So you can read it by color. You can read it by volume, so how much smoke is coming out. A lot of smoke, a lot's burning. A little smoke, only a little's burning. And a really important one is its velocity, which in plain English just means how fast it comes out. So one type of way that smoke comes out is called laminar flow. So there's laminar flow, which just means like light moving smoke. It's just kind of trickling out of the structure, and it's not really being shot out. It's not pressurized. It's compartmentalized. So that usually means that just the contents inside the structure are being burned usually, and the structure hasn't really taken off yet. So the opposite to that is tubular flow. So when it's pressurized, so if the smoke is being pushed out and shot out of the structure, that means that there's a lot of energy behind it, a lot of heat. It's pushing and pulling and creating its own atmosphere. So with that said, if you have a hallway, some rooms have laminar flow, it's just kind of coming out, and then other ones are pressurized. You're going to know that where the pressurized smoke is where the seed of the fire is, and that's where it's the strongest, so you can go for your attack there. So for the final demonstration, I'm just going to go through the 4 stages of fire. So this is the incipient phase, where it's just kind of starting off, nothing much. Now we're moving on to the growth stage. It's starting to get hotter and hotter and more rapid combustion. So now it's kind of fully involved, everything's catching, and this is where it burns the hottest. And now you get into the decay stage. It's starting to die out, everything's losing, and at this stage the fire is just short from being over. So those are the 4 stages of fire, a little bit of fire behavior, the fire triangle, and smoke and how to read it.